Hi, my name is Song William, and today we're going to be talking about motion and force. So first off, what is motion? Well, motion is when an object changes position over time when compared to another object. Motion has to do with reference frames. Reference frames are places or objects used for comparison to determine whether something is in motion or not. Usually, good reference frames are things that are fixed to the earth, such as trees, stop signs, or buildings. Motion is also relative because it is determined by a reference frame that can change. So when you describe motion, you have to say something is moving relative to some other thing. Let's look at some examples. So in this example, there's a tree and a yellow person and a red person. The yellow person and a red person are on a cart moving towards the left. So if you were the tree and you're looking at the cart, then because the cart is moving over time, you would say the yellow person is moving. So relative to the tree, the yellow person is moving. But if you're the red person, then because you guys are in the same reference frame in the same spot, the yellow person isn't moving relative to you. Because even if the cart moves, the yellow person doesn't move. So relative to the red person, the yellow person is not moving, but relative to the tree, the yellow person is moving. Let's look at another example. So in this example, we have you standing on the earth and the sun. So because you're standing on the earth and not moving at all, you are not moving relative to the earth because you move with the earth even when the earth moves. However, relative to the sun, you are moving because the earth moves around the sun. So relative to the sun, the earth is in motion. So you would say that relative to the earth, you are not moving, but relative to the sun, you are moving. Now for types of forces. So there are two types of forces, contact forces and non-contact forces. Contact forces are applied when an object actually touches another object. A real-life example of this is friction, which is a force exerted when two surfaces rub against each other. You can see in this picture that this person applies a force to the box going towards the right when the person presses it, but because of friction, it keeps the box from sliding on forever and ever and not stopping. But because the person pushing it to the right has a greater force than the friction, the box moves to the right. We'll get more into this a bit later. And for non-contact forces are applied to an object whether it touches the object or not. So it doesn't matter. So a real-life example of this is gravity, which is a force that pulls objects towards each other based on their masses. Some other examples are magnetism and electrical forces. There are also balanced and unbalanced forces. So to talk about these, we have to know what net force is. Net force is the combination of all the forces acting on that object. A balanced force is if two forces acting on one object are equal in strength and opposite in direction. So for now, just up and down or left and right. And the balanced forces have a net force of 0. Unbalanced forces have a non-zero net force acting on that object. This causes a change in the object's motion. For when you're calculating the net force of an unbalanced force, if the forces are going in the same direction, then the net force is the sum of the forces. If the forces are going in opposite directions, then the net force is the difference in strength of forces. So a force is a push or pull, and it's described by its strength and its direction. So how strong it is and what way it's going in. So up, down, left, or right. When you draw diagrams, you draw an arrow to indicate the force. The arrow points in the direction of the force. So if you're there and then you have a box to your right and you're pushing on the box, then the arrow would point towards the box, so towards the right. However, if you're pulling on the box, that means you're applying the force towards yourself. So the arrow would point towards you, so towards the left. Now the unit for strength of the force is a Newton, also written as a capitalized N. Capital N, not lowercase n. Now let's look at this diagram. So in the first diagram, there's a yellow ball which has a significantly smaller mass than the blue box, and so gravity pulls that down. However, if we flip this diagram upside down, then the blue box, which has a significantly larger mass than the yellow ball, is pulled down by gravity. And because gravity has to do with mass, the more mass there is, the stronger the pull of gravity is. The arrow is much longer than the arrow here because more force is being exerted here than here. So you can see that. Now for an example with balanced and unbalanced forces. So in this diagram, there's a table and there's a green ball. The force of the green ball being pulled down is equal to the force of the table keeping it up, so these forces are balanced and the green ball doesn't fall through. However, let's say someone puts a net over the green ball and starts to pull it towards the left. Even though there is friction, because the force of the person pulling the ball towards the left is much stronger than the friction, it causes the ball to move towards the left. So this is an unbalanced force because there's a non-zero net force being applied to the object. Now we have two blue blobs. These are the exact same, so they have the same properties, same amount of strength, same everything. So let's say these guys both apply a force of 2 newtons onto the yellow ball. Well, because this force is going towards the left, so we can represent that as negative or positive, whichever one you want. In this case, I chose to represent it as positive, but you can represent it as negative. So we'll think of this as a number line and think of the ball as a 0. So if this is 0, then we can think of this as just positive 2, and we can think of this as negative 2. So then that means that if we write this as a mathematical equation, then we'll get negative 2 newtons plus 2 newtons is equal to 0 newtons. So remember, if something is 0 newtons, then that means that the forces are balanced. So this diagram shows a balanced force. Now let's say we have a green blob and a blue blob. The blue blob applies a force of 2 newtons onto the yellow ball, and the green blob applies a force of 6 newtons onto the yellow ball. So because they're pushing the ball in the same direction, they aren't opposing one another, so we add them up. So we have 6 newtons plus 2 newtons is equal to 8 newtons. So this is an unbalanced force, and there are 8 newtons of force being applied to the yellow ball. Now let's look at a diagram with a green blob and a blue blob. So the green blob can apply a force of the strength of 6 newtons, and the blue blob can apply the force of the strength of 2 newtons. So now we'll think of this like a number line again. So this is the 0, the ball is the 0, and then we have 2 newtons here, so we'll put this as negative 2 newtons, and we have 6 newtons here, so we'll put this as just positive 6 newtons. So then we have negative 2 newtons plus 6 newtons is equal to 4 newtons. But because force, you have to write direction with it also, you wouldn't just say 4 newtons, you would say 4 newtons to the left, since the green blob, which has the greater force, is pushing towards the left. So 4 newtons to the left. So in this diagram, the blue blob and the green blob are pulling on the yellow ball. The green blob has a force of 6 newtons and the blue blob has a force of 2 newtons. So again, if we think of this like a number line, then this is the 0 and this is negative 2 and this would be positive 6. So we have negative 2 newtons plus 6 newtons is equal to 4 newtons. But because the green blob is the one with the 4 newtons and they are pulling towards the right, we have 4 newtons to the right. So this diagram here is 4 newtons to the left, and this diagram here is 4 newtons to the right. So a quick recap, motion is relative to another object, so when you're describing motion, you have to say something is moving relative to another thing. Force is a push or a pull. There are 2 types of forces, contact forces and non-contact forces, and there are balanced forces and unbalanced forces. Balanced forces are when the net force is 0, and unbalanced forces are when the net force is not 0. I hope this helped you guys learn a little bit more about forces and motion, and I'll see you guys next time. Bye!